Welcome everyone to the second session of iCEBreak webinar. Today is a perfect rainy day for a Zoom session. So our invited speaker is Lígia Rodrigues. She is Associate Professor with Habilitation at University of Minho, Associate Director of the Research Unit, Center of Biological Engineering, and Head of Department of Biological Engineering. Her research line activities are linked with industrial biotechnology and bioengineering, and she will bring us an interesting talking today entitled "The Educational Biosystem Breaking Boundaries to Shape the Future Leaders." Lígia, thank you very much for your presence, and the floor is now yours. As soon as you wish, you can start to share your presentation. Thank you very much.
Thank you, Ricardo. Just a second, sorry here. Is it okay? Yes. Okay, thank you for the introduction, Ricardo, and good morning to everyone. As you mentioned, the title of my talk is "The Educational Biosystem, Breaking Boundaries to Shape Future Leaders." And I must say that I use the term biosystem for two reasons. The first one, because I will be talking about the new chemical and biological engineering courses that are under the responsibility of the biological engineering department. Second, because besides being a faculty, I am a researcher at the Biosystems group at SEB. And in the Biosystems group, we use competences in systems biotechnology and bioengineering to foster the development of knowledge-based bioeconomy leading to new added value products and processes. So our research activities, they are based on bioprocess engineering and computational biosystems. And basically, we aim to generate, apply, and disseminate knowledge and tech transfer in life sciences, in biotechnology, chemical, and environmental processes. And you will see that why I believe that these activities, they are important and could be used to break boundaries in the current educational biosystem and be used to leverage our future courses. Actually, to be honest, I believe that all SEB group activities have that potential, and we will be able to see that in the coming weeks with the presentations from the different groups. So a system is a group of interacting or interrelated elements that act according to a set of rules to form a unified whole. A system surrounded and influenced by its environment and is described by boundaries, structure, a purpose, and expressed in its functioning. So if we look at our bio courses, and namely to the integrated biological engineering course, we can easily detect which are the boundaries that the main boundary that we have is a cultural one that comes from since our childhood and is very well rooted in our culture, and that is our sense of what is a classroom or a typical classroom where the faculty lectures for 1 to 3 hours using slides and the students sit quiet listening, and there is not much interaction. And teaching is only done by the professor. The topics are the same over and over every year. These are, in my opinion, the main issue or limitation to the change or the big change in the education. But I will talk about that later on. As for the structure, the structure, we don't have much flexibility here because it's usually defined by the university or by the School of Engineering or ultimately by the national educational patterns. Because all our courses, they are, let's say, validated or evaluated by the Agency of Evaluation and Accreditation of Higher Education. As for purpose, I think that the purpose of our bio courses is quite clear and unchangeable, and the functioning can be easily assessed by the student satisfaction and also, for example, by employment. So the question is, how do we evolve? And Evolution occurs when there is a change in the DNA that is, which is inherited from the parents, and especially in proportions of different genes in a population. And it takes place as new genetic variations in early ancestor populations favor new abilities to adapt to environmental changes, so alter the way of life. So bringing these concepts of evolution to our educational biosystem, it will evolve whenever we perturb the system, either by changing the environment or breaking limits, boundaries, and it will have to quickly adapt in order to survive. A recent example can be, for example, what happened with the way that the educational biosystem responded to the pandemics. If you recall, we changed from 100% face-to-face education to 100% remote education. And of course, that you may ask if it was perfect. No, of course, it was not perfect. But it was something that had to occur. So we had this perturbation in the system and we had to adapt. We are still making adjustments with the blended system, and we still have to evaluate what will be the impact of these changes. But one thing is for sure, DNA has changed and we will never go entirely back to the old system. So where are we currently standing? We have a team of committed and highly motivated faculty and researchers. We have very dynamic student associations. We have recognized science, and we have initiatives for the students and from the students, as well as our stakeholders, academic partners, industrial partners, and of course, our successful entrepreneurs, and many, many more. I should say that the students, they are our best ambassadors, and we actually need to involve them in our activities, which is because this is really important, so they get the sense and the feeling that they are part of the community. So they have been involved in a number of activities like UPA, Verão no Campus, and when we have visit schools to the department and the other way around. So what are our weapons or our tools? The department is committed with innovating in the teaching and learning process, and for that purpose, we have been organizing workshops, so-called oficinas de inovação pedagógica, and also some science communications under the scope of the CC Biotech project. But also, it's important to say that the university has a number of webinars and training courses available through Idea Center, for example, Docência Mais. And I must say that our faculty and our researchers, they have been attending a lot of these courses. So we have a high percentage of people that have done this sort of training. We also have excellent and recognized science, and of course, faculty and researchers with very strong backgrounds and relevant networks. But the most important thing is that we are working on hot topics that are well aligned with EU priorities and that will definitely shape our future. And I can say that it will definitely shape the future of chemical engineering. And just to name a few of these topics, we are working on food, health, clean energy, bioeconomy, bioprocesses, environment, nanotechnology, bioinformatics, and so many others. So there is a big opportunity. In the next scholar year, 21-22, we will start our new courses, the Bachelor and Master in Chemical and Biological Engineering. Major challenges are expected as the transition processes are always complex, they are painful, they are hardworking. However, I believe that this change is a unique opportunity to evolve our educational biosystem, breaking the boundaries, resetting whole practices, and innovating towards a more meaningful teaching. So we have put up two courses, the Bachelor and the Master in Chemical and Biological Engineering, and I'm not going into detail on these plans. I only want to say that these courses, they are beyond the old school chemical engineering courses with traditional pillars of unit operations and transport phenomena or petrochemistry and heterogeneous catalysis. These new courses, they are actually focused on the production of new improved products, well aligned with the customer needs, based on new technologies. And actually, it's all about efficient transformation of raw materials that preferably should be renewable and energy into target added value products without polluting, without waste. So a big focus on sustainability. These courses, these two new courses, they also imply things like multi-scale modeling, new production schemes, new processes, integration with life sciences, a lot of multidisciplinarity and emphasis in soft skills. These soft skills, they are key for the new chem bio eng jobs that need to be global and that need to be fit into cross-functional teams. So these courses, they have been designed based on innovation drivers. For example, market differentiation and enabling technologies. And I must say that they are well aligned with two megatrends that shape the chemical industry and will shape in the decades to come. That have to be with decarbonization and biotechnology. We know now that most chemicals will in the future be produced from microbial sources rather than fossil-based sources. So very briefly, looking at the courses, of course, that in the bachelor's you can find a higher amount of courses that are more engineering related courses, and then you see in the master more speciality or let's say emergent topics covering all the aspects that I just mentioned. So teaching is a powerful tool to shape the next generation of leaders, and by leaders I mean innovators, scientists, entrepreneurs, and all sorts of professionals, which comprises, of course, a lot of pressure and a lot of responsibility for the faculty and for the researchers. Of course, there is no such thing as a free lunch. This will require a huge amount of time, dedication, and preparation from the faculty and researchers' side. But I should say that the best reward ever is when you realize that you have made a difference in the student's life, and ultimately that you have contributed to some sort of impacts, scientific, societal, or economic impact. So I think that faculty are active players, of course, but faculty are normal people, and as anyone else, they must be motivated. And teaching should be fun. Happy faculty bring their joy to the classroom. So when we prepare our classes, we should put ourselves in the shoes of the students and think, what and how would I have liked to hear about this subject? Or would this class as it is interesting enough, is engaging enough? What can I bring to this class to give it context from my science, from my experience? Because we actually need to stimulate the willingness to learn. When we were kids, we used to ask a lot of questions, but something happens in the process when we are aging. And the question is, when do we stop being curious? Is it a matter of too much education or aging brain, or it's just too much information or useless information? I don't have an answer for that. But what I know is that curiosity is key to science progress and is key to learn. And motivation and context makes all the difference. So active learning is the best way to engage students in the process. And breaking boundaries is a lot about that. Not only, but a lot about that. And engineering topics, we all know that they can be very hard to teach in an engaging way. For example, mass or heat transfer. But active learning is possible, and we need to change the paradigm. Usually these topics, they are taught to the younger students when they are just arriving to the university, so at the bachelor level. And for these students, it's even more important that we can explain them why is important for them to learn these topics. It's crucial to raise their interest and to stimulate their curiosity. We can use teasers to start a class, and this should keep them focused. We can just ask a nonsense question like why scientists don't go to heaven, or just pick something that is in the news. This will at least keep them engaged in the class for the initial moments of the class. Who cares? Who cares? It's all about context. We need to engage them in active learning, and it's crucial to give them real challenges. I bring here some examples, and I'm not going into detail in all of them. There are many examples at our department and from our faculty in different courses. For example, the first one that is on the top of the slide, the 0H, is an example of an entrepreneurship project developed by bioinformatics students that proposed the use of artificial intelligence to develop personalized recipes of craft beer. So these students, they had to pick a lot of information from scientific papers. They had to couple here their expertise, their knowledge in bioinformatics, and they had to, you know, step out of their comfort zone and work on an entrepreneurship project. There are many examples of this in our courses, and this is the way I think that we need to teach them to think differently and how to relate things and not store the information on the drawers. We need to raise wildcats. We need to stimulate their curiosity. We need to challenge students and make them search for the information. We need to put them in the role of the professor and listen to them. And most importantly, we need to give them timely, clear, and fair feedback. Developing of soft skills is crucial, as I mentioned. The new jobs, and the actual jobs need them, but the new jobs will be much more challenging in terms of soft skills. What can we do differently? We need to leave our comfort zone and try new teaching activities. For example, flipped classrooms, debates, gaming, and many others. We need to team up with the students. We need to make them our allies, assume a mentor or a catalyst role, and this is the best way to overcome the challenges. We need to have respect in the classroom. The students must feel comfortable and trust not only the faculty, the professor, but also the other colleagues if we want them to fully engage into something different. We need to listen to them. This is key to understand if there are any issues and if they are struggling with any of the proposed activities. And most of all, we need to tell them what are our expectations and learn about their own expectations. Tell them what are the plans that we have for that class or for the course and how the proposed activities make sense. Why are these important for the learning process? Other things that we can do differerently is promote networks. Teamwork is not only or should not only be at the students level, but as a whole educational biosystem. The way that I see it, the educational biosystem is a contact sport that involves PIs, researchers, faculty, students, alumni, associations, employers, and so many others. And all of these should contribute to make the course better and unique. We could design pilots, and by pilots, I mean interconnecting or relating 2 or 3 courses to give meaning. There are some good examples already at our integrated master in biological engineering. We can propose projects and activities based on science. We can also make students feel special, motivate them to engage extracurricular activities, especially those from them, but also others. For example, BISC-E, Idea Lab, and so many others that we have ongoing. This will help us building a stronger biosystem, will help us to build trust and enjoyment. Also, we need to be international if we want to step forward. It is of utmost importance that we can offer some of our courses in English. English is the language of science. And without that, we will not be able to exchange in and out students with reputed engineering schools. We can also benchmark with the most relevant Portuguese engineering schools. Maybe, who knows, build a pilot with joint classes. And I also think it's important to have a greater involvement of the order of engineers. Another key point is the voice of the customer. So teaching is an investment in the future leaders. It has an impact in education, in society, in economy. It is mandatory that we hear the employers, that we hear the voice of the customer. We should involve them as much as we can in our courses, not only internships, but also seminars, day trips, visits, contributions to the new curriculum. It is important, and we need to make sure that there is a perfect match between their expectations and what our students actually know and are actually able to do. And we should never forget our alumni, because our alumni, besides being positioned in good places, so they are employers now, they can always give us good feedback on things that we can improve in our course. Finally, I see science as a driver for the change. Science is everywhere and should be everywhere. Science should be the basis of the curricula, so we can get students more motivated and actually students learning topics that will definitely shape the future courses, the modern chemical engineering. These students, they will for sure be greater professionals, and they will have the ability to innovate industries, companies that can also feed science with their problems and can also feed the learning process. So I bring you here an example of what I see as a very interesting educational biosystem. I had the opportunity in 2019 to be a jury in this competition that is called the IGEM competition, International Genetically Engineered Machine. This is brought out by the IGEM Foundation, which is an independent nonprofit organization dedicated to the advancement of synthetic biology, education and competition, and the development of an open community and collaboration. This is a great example. Here you have students coming from high school. You have bachelor students, master students, PhD students, postdocs, researchers, PIs. You have companies. You have a whole community working on real problems that are fed by society or by companies, and that the students work as teams. Of course, it's a competition. They work as teams during a whole semester or the full summer. And then there is this major event where teams show their outputs. Many companies have been created from this. For example, Ginkgo. Ginkgo has been created by Jason and Resma, which were the first ones involved in the development of the IGEM Foundation. So, wrapping up, science. I see science as a driver for the change. Excellent teaching will lead to excellency in science. Researchers with stronger backgrounds, networks, leaders, able to think out of the box. This will bring impact in society because they are active players to disseminate knowledge and contribute to scientific literacy. It will have impact in economy because we will have great professionals with a strong sense of how to innovate and how to solve problems, evolving more conservative industries and pushing new deep tech companies forward. And of course, an impact in environment because they will have greater awareness of the needs that we have to take care of our planet and sustainability concerns. A scientific-based learning to give context, engagement and joyfulness, listening, stimulating curiosity and making fun and appealing is key. Faculty must take the risk to do it differently, but students must take the risk to step out their comfort zone. It's all about changing attitudes. It's all about changing minds. And our mission is to shape future leaders by offering a course that is innovative and well aligned with the EU and United Nations priorities. Thank you.
Thank you very much, Ligia, for this insightful presentation. I think all of us are inspired now. And we also have several questions. I will try to share some of them. Here is. Okay. So we have the first one that is the most voted one. How do you see teaching in the next forthcoming years when things go back to expected normality?
Well, I don't think that we will go back to what we had before. So that was my initial message. I think that we have somehow changed the DNA, and I think that we will have a different way of teaching from now on. But yeah, but I hope that we will have more opportunities to interact with the students, definitely. And as I mentioned, I think that we need to make an effort to have more active learning in our courses. It doesn't mean, I don't mean with this that we should change everything to active learning, because we also need to balance the effort that we put on the students' shoulders. And these kind of activities, they can be time consuming, and they are really challenging for the students. I think we need to get a balance on that. But yeah, so the way that I see it in the forthcoming years, the return to let's say normality yeah, I think that we will have opportunities to have more interaction with the students, and we should somehow shape the way that we teach to have more active learning in our courses. What are the main advantages of the new courses? That's the next question. Well, I think that these new courses, they have been designed very focused on first on the students. So trying to get courses and activities in that can give them meaning first. And on the second, on the other hand, also, these courses have been aligned with the voice of the customer, so the employer's perspectives of what should be the competencies and the expertise of the students, of the professionals when they leave the university. So these are the new things. I mean, we have a lot of old things, but the programs and the curriculum have been changed to fit better the students' needs and the employer's requirements.
Okay. Thank you. We have also one that is very interesting. How is Deb's board motivating teachers to do their best in this situation?
Well, we have been putting some effort on the development of some workshops, some seminars where we have been, let's say, showing some case studies and some examples of things that really work. On one hand, on the other hand, we have some projects, some educational or innovation in educational projects ongoing, where we have been involving different faculty as smaller teams to try pilot experiments and to see how it works. And then, of course, the idea is to bring on board all the other people. Also, as you may know, we have a lot of let's say young faculty, which are the researchers that have recently joined let's say the faculty community and that are involved in the teaching process. And we have been really focused on the researchers because we believe that they have let's say fresh perspectives that they can bring to the courses, but they also need to have some guidelines and motivation. Yeah.
Okay, thank you, Ligia. I think we are running out of time, so we will save the remaining questions and we can try to answer later then. Before closing this session, I just wanted to make two reminders. Next Thursday we'll have an iCEBreak PhD edition that will be only for PhD students, with presentation of Diana Guimarães, and PhD students from SEB. And on the day 27th of May, we'll come back with the iCEBreak webinar open to public, with participation of Professor Paul Mendes, Director of the Center of Microelectromechanical Systems from University of Nîmes. So I hope to see you next time, and I also want to thank you, all of them, to joining us. So see you and thank you very much. Thank you, Ligia, for your participation.
Bye.